Greetings to everyone. So today we are going to study about how to prevent this corrosion. So you can design, that is to prevent corrosion, you can design something new. That is, design of structures can be modified, then material selection, cathode protection, reduce the activity of the cathode or electrolyte, that is polarization, then protection of the anode, that is passivation, and then alteration of environment inhibitors. So here we can avoid the sharp corners, that is in design of structures. Sharp corners can be avoided. Then complete draining of vessels. Avoid sudden changes in sections. Then avoid contact between dissimilar metals. Then welding rather than riveting. Then easy replacement of vulnerable parts. And then avoid excessive mechanical stress. All these are the diagrammatic representations of the above ones. Okay, so you can just see the diagrams and then we can see how these are different. So avoid water accumulation in the outer construction, then this is the preferred ones. So see the edges here. So all this is the welding which is done. So preferred parts are going here. Then material selection. So metallic as well as non-metallic parts. So then improvements of materials, there is purification of materials by aluminum, zirconium, making more noble, that is platinum and tin, titanium, then passivating, that is chromium and steel, inhibiting arsenic and strontium in gas, then scavenging, that is titanium and niobium, improving other properties of the materials. Then we have cathodic. So cathodic protection. In cathodic protection, to control corrosion of a metal surface by making it working as a cathode of an electric device. So if you make the anode to behave forcibly as a cathode, then the corrosion does not take because cathode is the protected part of an electrochemical cell and anode gets oxidized, so that is why it gets corroded. So this is achieved by placing in contact with the metal to be protected another more easily corroded metal to act as the anode of the electrochemical cell. And cathodic protection systems are mostly used to protect steel, water, fuel pipelines, storage tanks, steel power pipes, ships, offshore oil platforms, and onshore oil well gaskets. So types of cathodic protections are of two types, that is sacrificial anodes, impressed current cathodic protection, and then galvanized steel. Okay. So here, the sacrificial anodic protection, anodes are more active, that is they have more negative potential than the metal of the structure they are designed to protect. So the anode pushes the potential of the steel structure more negative and therefore the driving force for corrosion halts. So the anode continues to corrode until it requires replacement. So if you see this diagram here, iron is connected to magnesium, right? So magnesium, if you see the electrochemical series, magnesium is present above iron. So it has more potential to undergo corrosion than of iron. So what happens is, because this is more active in nature, this undergoes corrosion first, this getting protected. So the iron gets protected and magnesium gets corroded. Okay. So as this gets corroded, you can remove this and replace it with another more active metal than of iron. So this is called as sacrificial anodic protection because magnesium is behaving as a sacrificial anode. Okay? So it is sacrificing itself for iron. So that is why it is called as sacrificial anode. So if we are connecting the more active anode to the metal, then this undergoes corrosion than the base metal. So now iron is called as base metal, and this is the active metal. So when a base metal is connected to a more active metal, the more active metal undergoes corrosion, and the base metal gets protected. They can replace this also. So the magnesium rod will protect the steel pipeline from corrosion. Magnesium is more easily oxidized than iron, therefore acting as an anode in galvanic cell. So the steel pipeline becomes the cathode and oxygen is reduced, in turn protecting the steel pipe. So this steel pipe gets protected. Next, coming to the impressed current cathodic protection. So this is done for large structures. Actually, the sacrificial anodic protection is used in ship hulls, where the ship hulls, that is the base part of the ship, will be in water, right? So, as you all of you know that water makes the metal corrode. So what they do is they connect this base metal to a more active metal, and that undergoes corrosion. So sacrificial anodic protection is usually used for ship hulls. Now coming to impressed current cathodic protection. So this is done for large structures like pipes, offshore platforms, etc., where galvanic anode cannot economically deliver enough current. So coming here, if a direct power is connected to the base metal, suppose this is the metal to be protected, that is why it is called as a base metal. Now this is connected directly to a DC power. Okay, and there is a anode here, and this anode is inert in nature. Okay? So this does not react. So what happens is, when you connect a direct current, what happens is this becomes your cathode. So you make anode forcibly behave like a cathode, and just the anode, that is, this is inert in nature, so that is why this will be protected. So thus, making it behave like a cathode, it gets protected. So in impressed current cathodic protection, what you are doing? You are applying the direct current power so that the anode forcibly behaves like a cathode. Okay? So that is why this process is called as impressed current. So you are applying some current, impressed current cathodic protection. So we have seen two types. So the basic principle of cathodic protection is to make forcibly behave anode as a cathode. Then only the anode of the metal will be protected from corrosion. So in this cathodic protection, we have seen two types, that is sacrificial anodic protection and impressed current cathodic protection. So in sacrificial anodic protection, we have seen that the base metal is connected to a more active metal, where the more active metal undergoes corrosion. Right? In impressed current cathodic protection, we have seen that it is connected to a dark, base metal is connected to a dark current power, so where this anode is possibly behaving like a cathode, and thus the anode of the metal gets protected. So these two are very, very important, right? So this impressed current cathodic protection is can be seen in the pipelines below the ground. Okay. So their pipelines, the offshore platforms, etc. We can see this impressed current cathodic protection done. Okay. So these two are the main um, things for cathodic protection. Then the earlier design structures. The design of structures, then material selections, then improvement of materials, and then cathodic protection. So all these types are very, very important in protecting the metal from corrosion.